Okay, team. Good evening. Thank you for joining today's session. So today we are actually be discussing about Dockers. First, this is we'll be discussing first Dockers. Okay. So here we will understand how we can work actually in our like actual environment. So we will actually be discussing below this is a topic we'll be discussing. But for now, in today's session, we will discuss the first maybe the module one and second module. That is getting started with Dockers and also creating image management and the registry. Okay, so we will see how what one could be covered here in this session. So like we all know that we have heard many times like Docker, right? So what exactly the Docker is? So as you can see here, the Docker is an open source software platform that simplifies the process of building, shipping, and running application by using containers. So we have to understand here three things here. When I say containers, sorry, Dockers means it is a process of building, shipping, and running, right? Building means, let's say when I say building is basically your the kind of the thing for you have an infrastructure here. This is your infrastructure now. You have to build that like whatever you see. This is one of the, let's say this is infrastructure now. You have to build that first, right? You have to build that based on that application. Let's in our case that is some particular ASP.NET Core or Java based applications. Based on the existing application, we will build the uh, this thing, right? We will build it. Once that is ready, then we will shipping. Shipping is nothing but you're deploying. Deploy mean anywhere you want to deploy. It could be your any platform. Let's say your particular Windows based or Linux based or any environment you can distinct. And also that is running your application. You can then you can run that one based on like I mentioned, but using what containers, right? So we will definitely be understanding little bit as we learn slowly. For now, you just understand when I say Docker is basically the process of building, shipping, and running application by using containers. Okay, so let's see what next. So this is some of the key components of your Docker. As you can see here, the first one is your containers. When I say here itself, the mention container itself, it says running, sorry, using containers. Right? This all will be basically what is this, process of shipping, b- building, sorry, building, shipping, and the running application using containers. So what is containers here? So as you can see here, the container is basically nothing but is a lightweight, isolated environment that package and applications code, runtime, the system tools, and system libraries and settings. So in simple term, when I say the containers, is basically is a lightweight and isolated environment which has your capability of your running your applications. That means to run any of the applications, you should be having like application core first thing, and then you will have a runtime, and also you'll have the system tools whatever it required for application to be run, and also definitely you have some libraries and also some settings, right? This is known as containers. This is the key component actually. This is some of the key component which is required for us to understand. Then second is our Docker image. What is Docker image basically? Sorry, not Docker image. This one, sorry, Docker engine, right? The core engine is responsible for building and running containers. So this is the first one, as we know. This is a basically this is isolated environment and it's a lightweight, which has the application core, runtime, and this thing. This has, but to deploy to run this one you should have something, right? To run to have this kind of you should have somebody will be responsible to take care of this task basically to do the container, run the container, stop the containers, any kind of this thing, right? So if you see here the definition, it says that the code engine responsible for building and running containers. Because when I say this is all deploy, but this has to get deploy or this has to get this thing, right? Who will manage that one? This will manage by this guy. That is your Docker engine. So the Docker engine basically responsible for building and running your containers. Container is basically nothing but container is nothing but it is again lightweight, isolated environment okay, which has your application code, runtime, system tools, system libraries, etc. Then this is very key point where we need to understand this is, but this is okay. We will also learn anyway. So when I say the Docker file, a script defining instruction to create a Docker image. So let's say you have an application now here. You have an application that is let's say Java based applications. Okay, so the application could be for any kind of it could any application you can take of example. Think any example. Okay, so in my case, if you want to make this application as a Docker containerized base, how will you going to do? You have to have your Docker file. Docker file is essential. You have to write a Docker file based on the your existing application. Let's say you have an application. Another example, give ASP.NET Core where you want to deploy in your Azure CI/CD pipeline, right? So for that one, normally what we did was before we did using our manually in the sense not manually. We artifacts we took and we pushed to the Azure pipeline and from there we deploy to our Azure web app, right? But here is a much more advanced level. That's something like what you do here. If you have applications like let me just show you that what I mean to say so that it will be which we were doing. I mean we think GitHub. Repos. Think we were doing last time this one. I'll open another DevOps so that you can relate what I'm trying to say. Pipeline. I think this one, right? I just share. Okay, I'll take one of the example. Is it not? Oh, not this one. I think this one. Oh, this one only. Someday, right? Correct. Okay. Say, this was created. Basically, we have used this one using our Azure CI/CD pipeline. But if you see what we did was here, the application code is here in your GitHub now, right? In your GitHub, you have this is complete your ASP.NET code, where it is located in your GitHub. You have all the like require like let's say system libraries, tools, basically dependencies, everything. That's basically your infrastructure, not infrastructure, application code is available here. But this is one of the way we can do it. But here, what we want is there. Here, if you see artifacts, what we did, we published the artifacts here. This is whatever code is there. This thing. Okay. So, but now, and also if you go to the pipeline, this all we have given in the pipeline, things like that. Okay. This all we have given. We have published the artifacts, everything. Okay. But what we want is here now, when it comes to Docker, what he can do, whatever you're using the Docker file, whatever you have an image here, basically image, not image in the sense your application code you have here. Okay, whatever application code you have in your GitHub now, that has a particular application code, right? This one. Now this one, how can I containerize this application using Docker, right? Meaning whatever code is there, that need to convert into Docker file. Okay. So before that, we also need to understand other components also because all together they work. Okay. So when I say Docker file, basically here it's a script. Okay. It's a script. Okay. That the instruction to create a Docker image. Instruction for what? Instruction for your this thing. If I see here, I have given the code here in my GitHub here. I have a code now. I need to now I want to deploy this application in my this thing in a pipeline. So for this one, I want to use a Docker by using Docker file. So Docker file basically will help you. This will give you the instruction what to do what. Let's say what is the first step I need to do, what is the second step I need to do. So basically the instruction argument you need to define in your Docker file. You will learn that one as we learn as we go further. Okay. So let's see what's next. Basically script defining instruction to create a Docker image. Now you can see Docker image basic nothing but it is a snapshot or template used to create containers. So basically for Docker image nothing but it is snapshot or template used to create a create a containers. Now when I said the here Docker container, basically when I say Docker container, basically it's an executable package containing applications and its dependency. Okay, it contains your executable packages, basically nothing but your application packages containing and also dependency. Then then we have it Docker Compose. This is basically a tool for defining and running multi-container applications. In simple terms, if you had to deploy your application in many of the let's say environment or multiple applications, right? Now in our case, for the first time, we use normally only one. But here, if we had to deploy multiple applications like container-based application, how are you going to do? So this will basically help you identical environment will be deployed basically with the help of multi-container application. Okay. So when I say the like Docker Compose, basically in simple term, it says that the defining and running multi-container application. That means instead of one applications, this thing you can have a multi-container application. You can have a multiple application. That means, and it has a multiple containers. Okay. Volume. Docker volume is basically persistent data storage for containers. So you don't have to understand now much this one, but as we will go, you will again and again you will learn this and all. So for now, you just understand what it says. But this is important. The containers, Docker file, Docker image, Docker container. This some of the are important. These and all you don't have to learn now. We will learn that slowly later. Okay. And we have a Docker network. Like network is everybody knows what is network, right? So it's mechanism for container isolation and communication. By default Docker has their that is managed by Docker itself. They have the network where it is managed by Docker itself, but then somewhere you want to control within the organization's policy or standardize, right? So in this situation you need to define your own network that we are going to discuss as we learn, right? So then we also have Docker registry. Docker registry nothing but it is a repository for sharing and distributing Docker image. Let's say now this particular applications you have written the Docker file. It is made as a Docker image now. The Docker image basically need to be somewhere located in your centralized repository, right? This code basically, not code basically. After moving to the Docker image, basically once it's built as an image, that will be stored somewhere in your local somewhere repository. In my case, I have it uh, Docker Hub. Okay, this is some of my emails basically. If you see, I have some of the emails I have used it before. As you can see here, this is one of the my SCR, that's Azure Container Registry, my India app. So I have built this one. I have pushed in my as a code to I moved from code to iSense into the containerized base. Okay. So if you see here, you will get what is there, what is not there. You can see, you can pull this one, use it anywhere. Okay, you can use anywhere this one. So I can just use it, this one Docker push if you want to push it. But in my case, pull mean from the here to I want to pull in your local system or wherever you can use a pull instead of push. Push mean you're pushing, right? So tag is basically a version of your this thing. This thing changes whatever you make. You can see here we have one tag that is your okay. So if I go inside here, you can completely see. Yes, you can see how it has been written. Okay. how it is been written, you can check Docker file. Docker file move this thing. That you don't have to think much for now. Just understand when I say that Docker Hub is basically this is a public repository. I think I didn't explain that one here. Yeah, Docker Hub is basically is a public repository of Docker images. Let's say you have now applications which is based on your Docker image. Let's say you have an image now as a Docker image somewhere in your local system. You have done using help of your Docker file, right? Docker file basically has your instruction, what kind of the task to be done or argument it or maybe instruction you need to define in your Docker file. Once you define, that will be based on your existing application. You have to give a Docker file, right? You have to write that based on your existing applications. Okay. Once you define and once you have the Docker file in place, then we will have the Docker image will be in place, right? So once you have a Docker image, what you will do basically, you have some way to, let's say in your local system now, that means now you cannot share those images to any of your team members or maybe any of the public publicly, right? So that is why we require one of the repository. In my case, this is a Docker registry also makes sense, but we can use this also. We will explain why we have to use. There are two different meanings. When I say Docker registry, basically in this thing, a repository for sharing and distributing Docker image. Okay. So one of the example we have when I say Docker registry, this is one of the Docker registry example, Docker Hub. We also have other that is AS. If you're talking about Azure, we have Azure Container Registry. That is same as Docker Hub, but this is a public repository. Okay, but if I talk about the ASR SCR, that is Azure Container Registry, that will be your private. So some company they don't prefer to use a public. Normally they use their own the repository where they can store all their images, right? So they don't want to store here in your public repository, so they use their own repository that is again based on the provider. My case, if I talk about Azure, it will be a Azure Container Registry. If I talk about AWS, Elastic Container Registry, like that for AWS. So it depends on the provider to provider and how they want. Okay, so in my case, because we are actually be talking, I mean, we are talking about Azure, so we will talk about SCR, that is Azure Container Registry. So I hope this is clear, team. So let's see what's next, Ben. All right. So when I say the Docker this thing, right, we need to understand what can be so special here as compared to our traditional, right? So we need to have some benefits. Let's understand some of the things which we need to understand as a benefits, right here. First thing is the portability. It's very interesting, right? Runs applications anywhere Docker is installed, regardless of the operating system. That is what I was discussing before. Discussing, and also means you can, if you have a installed your Docker in any of your application server, then means you are good to use your Docker. Okay, you can use a Docker then, regardless of any operating system. Seamlessly move between environments. Let's say if you had to work with one of the environment, let's say for some reason for testing you want to create some other environment, or your code testing or anything you want to have different environment. Yes, it is possible. They will help you to create separate environment and work based on them, just like a branch how we use in our Git, right? Whenever we want to do some modification or we want to change something, we create separate branch, and within the branch we do modification and uh, we will push to the remote and we will merge it based on that. Basic merging the sense we will pull the request. Okay. Similarly, we also have in Docker thing with that consistency, right? Apps always run in the same isolated environment, ensuring predictable behavior, eliminates work on my machines issues and the stimulus testing. Yeah, that's mentioned. So like I mentioned, this is again same isolator and ensuring predictable behavior. Because if you work with your within your what is there environment, if any changes happen also, it will be affected within your branch. Sorry, environment itself. It's not gonna have any kind of issue to any other environment. Okay. Then isolations. Isolation can be many ways. Some of the things like it is like a security and resource management by isolating apps from each other and prevent conflicts and vulnerabilities. Definitely, if you work in multiple this thing, let's say in within this thing, separate brands, if you environment, if you have, you can isolate your this thing. You can isolate even your net security, your network, your resources, everything you can have. Okay, so it will not even conflict also will not happen because whatever changes is doing only within your environment itself. Then this is a fourth number is usability, right? First, the development, testing, and deployment cycles. As we all know, in our agile methodology, what we do was we will based on the requirement, we will send this here. We same thing here. You can first the development, testing, and then deployment circle. You can see the second one option. It says that the facilitators continuous integration and delivery. That is rapid updates. We can have this one in our this thing. That is why we will have to learn this part about DevOps. Then we also have a open source, right? As we all know, like this is like I mentioned also already. So when I say Docker itself is open source, right? Open source, free to use, modify and distribute, fostering innovation and the community, and avoid vendor lock-in with open standards. And we also have the same collaborations that we, like I mentioned already, we can have a collaborations, and we have the maintenance and updates. This is also very useful like update apps and dependencies within the containers without affecting the other parts. Just make this. When I say if you have multiple containers, if you want to update some particular patches or particular dependency or particular tools or whatever it is, you can this can be done within your container itself, not entire your this thing, right? So this will not affect to any of our container. Only the specific containers will be affected that you have which you are working with. Rollover update also possible. That also has this thing. It can minimize the downtime as well. And scalability. Scalability, what way is this scale ups horizontally by adding more containers to handle increased loads. In the sense, when I say horizontal means in simple terms, you can have the number of this thing, right? Scale. If you have a multiple, let's say you have a more loads now. In some cases, traffic is more now and your container has some particular configurations or this thing that is not capable enough to handle the request. In this case, you can add more containers in that, so that you can then you can handle the request. Okay, and align perfectly with the cloud native architecture and the distributed systems. That already we know we can work with the cloud also in when we say in Docker. Okay, so then we will understand without like Docker. If you don't have a Docker thing, just imagine without Docker, what challenges we might have, right? If you want to deploy your application to any of these things. So first thing is your dependencies. Dependency conflicts will happen. The reason why is that application with conflict dependency will definitely have because you are working the in the specific server, or sorry, not like server, right? If you have, let's say you have only one server and you have run multiple application there, and one of the application that you wanted to update something, and maybe it will work for one thing, but when you see some other application, maybe some dependency on some other, right? So there can have a conflict there and can have a issue also there. That also a thing. Then we have a portability issues also. We have interest, we have difficult in running application constantly across environment. You can have in traditional things, but in Docker it is possible. And we also have the resource inefficiency. Sorry, heavy virtual machines consuming excessive resources. Like because if you don't have a Docker concept here, suppose you have some configuration of your 4 GB of RAM, let's say, and your application is only 2 GB of RAM, but you are wasting basically the resources another 2 GB, right, for no use. But if you have a Docker, this can help you save your that resource as well. You can see here how we can rescue the Docker can rescue here. Dependencies conflict, when I said Docker encapsulates dependencies within container, avoiding conflicts. So you can only the within a container itself, avoiding conflict you will have. Okay. Then portability, Docker ensures consistent application behavior across environment. Okay, that is again the based on the environment we can have that. And resource inefficiency, like I mentioned, this is a very lightweight, right? So you will not spend much your resources here. Only what is required they will be used because the container is just lightweight, so you don't have to have a heavy load of your infrastructure over there. And optimizing resource uses. See, as you can see here in a diagram, I have taken two different scenarios. The first one is the traditional what we are working on, or what we are basically in the this company we are doing. But some of the company, not some of the company, nowadays people are moved, everything, all companies are moved now here only. But see the example, this is your virtual machines concepts, this is your container base. So if I think two different example, first we have your, let's say resources you have, that is your Azure virtual machines or whatever VM you have it. Under VM we what we have a infrastructure, this is VM, we have infrastructure here, right? Here same thing infrastructure, till here we are good. But as you can see at this level, before what we have a virtual machines, sorry, hypervisor. We install hypervisor, right? If you remember, I also have one of the here. This is just give an example. Don't take it this time. This is some of the example I'm saying. I have it in my local. This is my local system hardware I have. Then I install OS there. Under OS, I have it my here. This is my VMware. That is hypervisor you think. Under VMware, I have one of the OS here. This is one of the OS. That is my Red Hat 8, right? So same thing here. It says that hypervisor I have. Under hypervisor, I will install the OS. You see here, I have a OS under hypervisor. I have a OS here. Okay. Then we have an application now under this OS shell. We will have to install the applications for this particular, let's say application one have will be occupied entire one particular OS, that is a guest OS that will be occupy one particular application. Same thing, another application will occupy another OS. That means if you have two here, if you have two application, that means you have to deploy another application here itself. That means now, but still, this is basically still we will be using entire, we will consume entire resources, but we will not be using entire resources, but it will be waste, right? So this is why, mm, ah, this is why we can think of using Docker. They can help you. So if you have a containers here and infrastructure, you will have that one. Then operating system we have. Then we will just install the Docker engine. Sorry, container engine. So container engine. So let's understand. Sorry, container engine. What it says? Container engine basically the core engine responsible for building and running containers. Okay. So when I say Docker engine, basically users need to install this Docker engine. So what he will do is his work is to building and running the containers. Simple. Users install this one. He will take care of this one. He will his responsibility is to build and running the containers. Okay. So he will under operating system just install this one. And if you have under here, you have your let's application one mean you have their own what do you call that libraries or any kind of this thing will be there. Same thing for application two, will be everything there. Okay. So whenever you have any issue here, you can just increase the container, basically the size of that one. If you have any loads here, you can just increase here. Okay. The containers basically you can increase the size. If suppose if one application is consuming less, maybe some other application has used consume some memory or RAM whatever. So in this case, based on the request, based on the loads, you can increase your container basically loads. Okay. Then this is just a conclusion if how is basically Docker not only tackles challenges but propels software development towards right forward. Its ability to enhance consistency, efficiency, and scalability makes it a must-have tool in the modern development. So developers toolkit. Okay. So this is I don't know how many of you might have gone with this installation. Just let me give a small brief so that it will be easy for everybody. Uh, this Docker basically can be installed many ways. In my case, sorry, here I given some of the example. Windows is very common. Linux also some people they use. Mac is used some people again. So this installation is pretty straightforward. Okay, so you can use this using this link. Okay, in my case, if I use the what do you call that Windows base, just I just need to click the link. It take me to the here. Okay, once you take me here, like I mentioned, here you will get you can copy paste the link however you want. Let's say if I talk about the Linux because we are mostly comfortable with Linux or Linux also is okay based on even you. Um, so what you do in your case, in my case, it's a you can see here, right? As soon as I click the link, it took me here. Now I can see here Docker desktop for Mac, but we don't have Mac. We're not working with the Mac. Windows, yes. Linux also, yes, we can work. But again, depends on your things. In my case, it's a Windows. So what do you do? Docker desktop to install. So if you click here, once you click the link, you get an option. Then you can see the what is required for them. You can go through the notes. They will mention everything here. Okay. The step is given here. Once you download this thing, you need to do these many things. So what do you do? I have already installed it, but just showing here once. Just run this one script. It will get installed the setup file for your Docker desktop. That is for your Windows based Windows based. Okay. One it is ready. Meanwhile, you can check your configuration what is required. That is not a big thing. It is normally supports. Okay. If you want, you can check that later, and you can check that one. Docker install Docker desktop on Windows. Okay. Here you can check it. What is required? Okay. I mean not what is required. Basically the setup. The steps is given here. So what it says that download the installer using the Windows button that we have already done here. Yes. Then second we have to double click on the this particular Docker desktop installer.exe. Okay. So I have already installed. I think it is still being downloaded. Let it get downloaded. Okay. Next we can go with the hard next prompt. Okay, it's downloaded. You see here. Okay. I have installed here. I can share Docker desktop installer dot is I got this one. Just double click. Again, team here one thing is that if you are working with your own like you are the admin for your system, mean it's good. Otherwise you need to create, let's say you if you had to work with other user, then it is in this case you need to set up your variable as well. But in my case, I this is my personal laptop, so I don't have to do that. So I'll just install this one. Double click, that's it. It's very straightforward. Just download the setup file. Just run this installer.exe. Okay. Just run this one. Uh, Once you run this thing, yes, it is asking me. It is getting is showing installing Docker desktop. Okay. They will try to see the version also. Whichever version is there. What are you asking here? Do you want to replace the current version? I have already installed it already. That is why I can check it. How I can check is you can open your CMD in your local systems in your Windows browser, type Docker. If you want to see dash dash, you can just version it type. Okay, so it will see what is the version. I have this version currently, but what it is asking now is if you see here, the version got this thing 23 point this thing. Okay, so basically the got changed, the version got updated. This is then what I'll do now. I will think asking 4.2. This was the old one. This is the new one. Okay. Okay. I will update one, the latest one. If you in your case, it will be just installed freshly, newly. It will be installed. Okay. Once ready, then we can go with next. Then what do you do next? We can see. Uh, then you can just here follow the instruction on the installation wizard to authorize the installer and process with the install that we have already done. Then you can close it. And you just as a note, this one, if your admin account is different, okay, if you use some other account, admin account, you to your user account, you have to do this one. You have to create a one user. Okay, you have to add here in this variable basically. Go under computer management, and then you type here administrator group. You go then local. Basically, just we need to add one more user. So we can just go computer management. We can type computer management option is there. Click there. Once user equal local user. If you go local user under user, here we have this thing, right? Here I mean we have so many users. You can have another user here. Then you can this thing. Okay, that you can do. You can see click on the new user. This we have to sign in, sign out, and sign in back because if you add it for the first time, I'm saying normally not required. Okay, otherwise once it is ready, we can start with our Docker commands. That's it. There's nothing much. Then you, as you can see here, once you this thing, you can start your Docker desktop. Docker desktop will help you to interact with your Docker base commands, basic command line interface. Okay, this will help you. Then once you register this thing, you can see where you have to go. It is nothing. Just go to desktop. I think it is been it's taking time. It's taking time for me. Okay. Okay. Meanwhile, let it take some time, not an issue. So what we will do, and once we are done with this one, one thing team here, just for your note, if you are using your hypervisor, sorry, yes, hypervisor and the VMware, the two things. Normally, if in my case, I'm using a VMware. Okay, so the reason why I use VMware is that if I see here, VMware. Yeah. So I use the VMware because I wanted to have multiple OS here. I want to for testing purpose. So I use this here. But even hypervisor also has hypervisor is already there's a pre-built with your Windows itself. Okay. If you type here hypervisor, you will have it. Is it spelling wrong? Hypervisor. Okay. Okay. Hypervisor is not there because I think I got this. I disabled it. Let me check. If it's the CPL, let me check. Okay. Okay, huh. I disable this one. I can enable. This is only okay by default there. You can just go here. Okay, then you just enable this one. Just click this one. It will get reboot. Then you can expand also. Then check. You can see hypervisor management tools in the hypervisor platform. Okay, these two you just enable it. Once you enable, you just mention as okay. Once you keep as okay, then it will ask you for you to reboot it. Okay, so if you reboot it, then your hypervisor you just uh, come here hypervisor you type here it will come here. I think in my case I disable it because I can't use hypervisor with my VMware together, so I wanted to use VMware. That is why I disable this one. In your case, if you want one of them you can use it, but both are similar, but I prefer to use VMware instead of hypervisor because I can see everything in one place. Here means I don't like much hypervisor. Okay, but anyways, depends on your this thing that you can work with that. So, okay, now you're asking close it. Okay, I'll close it. Can you see now?
Yes, yes, yes.
All right, yeah, thank you. So yeah, so I was saying about this one, right? So we can just click in the link and we are good. We have installed also. But in my case, I have installed already in my basically Red Hat that is located again in my here VMware. If you want this image, let me know. I will share it anyway. Okay. For resume, just this Red Hat basically for if you want to use for your Ansible, sorry, for Ansible is good, but if you want to use for your Docker base, I don't think so. It is a good this thing. I don't recommend. You can use Ubuntu instead. But if you want to use for your Ansible practice, root Red Hat is the best one. Okay. So let me log in with my ID. Sorry. Yeah. All right. So I will cancel this all. I have it, everything here. Uh, I will take a putty. I'll use from putty. This is my server. Ignore the name it's Ansible server because my main purpose of using this server was for Ansible only. But for now, I have installed Docker also here that you can use as well. So I'll use as root. I think the IP got changed or what? IP is correct only. It's taking time. Okay, it's taking time maybe. Okay, team. So I have installed it here. Let me increase the size. Font size I will increase. You can go if you want to use. Just click here in your put cursor. You just move somewhere here. Just right click, and there is an option called uh, here change settings. Right? Click here. Once you click here, you can see appearance. Click there under appearance. Then you can see the change option. Or if you want others also, you can change it. But in my case, I just want to increase the font size. So I'll make it as 16 is a good size. And I'll keep it as regular. Or if you want, you can change it based on your needs. So I'll keep it as 16. That is more than enough for me. Okay, now so we can ignore the VMware part. So because I don't want to deploy the cloud, so I just use my local one. So I can ignore this above one. So we can use this one. And Docker. Okay, team. So we'll see. So yeah, this is I just let me check first expand this one. Let me see what is the version right now. Docker, this is the version 20 is the latest one. Okay. So I will first I have created separate basically this thing I have already a directory where uh, I can run for Docker. So I will go there first cd okay slash etc and then Docker under that and like if here as of now I don't have anything but we will use it now. Okay, so what we can do is okay, now we are good with installation team. So like I mentioned, there's nothing much to do with installation. It's just simple installations. So we have already completed that. So then we will understand one more points. Then we will learn. Then we will start hands-on. Okay. First, understand. I wanted to be clarify two different similar case where many people they are not basically understanding the difference between this Docker image and containers, right? What is image and containers, right? So we will I'll try to explain in with the notes also. I have also made some notes. So when I said when I say the Docker image, right? Docker image basically is a lightweight we all mentioned here. It's standalone and executable package that includes everything needed to run an application, including the code, runtime, and this thing, and system tools. That means when I say image, basically it's just like a sorry, maybe GitHub. Okay, so this is let's say this is one of the application that I have. This is converted into using the Docker file, basic with the help of that. Then I have made a Docker image. Okay, this is all it says. Whatever it records the code is there, your any kind of system tools, everything basically will have here in your um, what is it called system tools, libraries, everything. Okay, what is required so needed to run an application. Okay, they know what if I had to deploy an application. So what is required for particular application to be run, right? So that is what it is mentioned, the code, okay, including the code, runtime, libraries, and the system tools, everything. And when it's a Docker container, basically, container is a running instance of a Docker image, encapsulating the application and its dependency in an isolated environment. So, like I mentioned, container basically just like a the containers basically just like a things where you keep as a isolated environment which you can deploy your applications or maybe you can run your applications, right? So yeah, let me understand first about Docker image. Uh, Before that, we will also need to understand about characteristics of your Docker image, right? So it is immutable, meaning once created, an image remains unchanged. Once you created whatever you're using based on the Docker file, image, whatever you have based on your application, once it is created as a Docker image, the image remains unchanged. You cannot be, normally it will not be changed unless you do. If you want to do it, you need to again update the core and need to once again update your basically the version based on the version. Okay, so it will be basically in simple terms. If I create something in based on my application, it remains same. Okay, unless you update new thing and you create basically you update it in your Docker. Then version, right? Image can have a different version for tracking changes. We all know that version is important because if I do today some changes, maybe for the, I'll have a tag. Tomorrow, if I do something, you'll have some other tag, version one, version two, version three, like that. So that will be easy for others or maybe for us to identify what changes made on what based on a tag. That also possible. Then also when I say this, a Docker image basically stores. Okay, images are stored in a registry, okay, in a registry for sharing and distribution. When I say this thing is image, we can store in our local system. Normally we can keep there also, but doesn't make it not be this thing. We always prefer to use somewhere in the repository. In my case, it is a Azure Container Registry, or if it is in your case, maybe you can use your Docker Hub as well. Oh, depends on however you want it. Docker Hub, again, that is your public repository. And if I want to use your Azure Container Registry, that in my case, it is a private Azure repository. Okay, for sharing and distribution. Because the same image I want to use, let's say now you are DevOps guy, you have done everything, you have containerized your applications, but it is in local system. Then other developer or other person cannot access this one, right? So this is why it is important the application, the Docker image to be available somewhere in centralized location so that other also can access and utilize it as and when they want, right? So it is basically sharing and the distribution. And we also have something known as the build instructions. It's very essential this one. Created from Docker file that specifies build instructions. It's nothing but if you created a Docker file from a Docker file, because Docker file, like I mentioned, basically this is a set of your instructions, right? So if I have application now, based on the application, what is my requirement? Based on the application, I need to give an instruction argument basically for my applications in my sorry for my application to here, that is in Docker file. So Docker file basically it basically is a set of instruction which you define based on your existing applications. Okay, let's say first I want to have a base image and everything that we will learn anyway, how to build, how to create the Docker file, that we will definitely learn. The syntax also we will try to understand. Then purpose, like what is the purpose? They serve as a template for creating a containers and a snapshot of complications environment at a specific point in time. And it also has a portable and consistent across different environment. Example, we can have like example building an image from Docker file. Okay, if you want to, you have an application now. Let's say you want to build the image from your Docker file, because Docker file you have given what to do. You have given all the instruction for your existing application. Let's say, okay, so you can just use this one Docker build command is very simple. You don't have to remember means for you don't have to be very hard to remember. It's very simple. Docker is always used because we deal about Docker. Bill is nothing but is again argument to do some task, right? Argument of your task. In my case, bill. Bill also you want argument. That means you want to build the image right from your Docker file. That is why we use a build command. Okay. Then we have a here. we have a your T, the terminal. Then we have your application name. Then your version. Application name means whatever name you have. In my case, these are image, right? Image, whatever name you can do based on that. Then this is your tag version basically. Then after this one, team, just to remember, if you see here after dot zero, there is a space you can see, right? This is not the together. You can have a bit of space. You always use the space and then dot. This also has a meaning. Okay. When I use the Docker build t dash t and then application name and then your tag name, then space then we have another dot. It's nothing but basically anything in your working directory what you have, this will be included. So if you have application in your my case, let me show you what I'm to say. Um, I don't have it here. Let me check. Maybe I have another thing. Can you see anywhere Docker file here? Eh, I think I created and I don't know. I don't remember where I created Docker file. Anyway, let me check in maybe here. Huh, good. See, this is the application running right now, existing. Let's say you have created Docker file. Okay, Docker file under here we have so many things. This is under application, right? This is your main application, basically the directory you have it. If you had to clone also use this one, right? You clone it with this one. And same thing, uh, this is all your packages we have it or any kind of we have a code. This is again your um, Kubernetes, right? This is your application code. Okay, this is a small one. You can have a big one. Okay, you see here, I have used my existing image. I want to pull this one, but for now, you don't have to think much about what it is. For now, just understand what mean the flow first. Okay, this is all service. This is again Kubernetes service. How to write this one? Very simple. We will anyway teach this as well. So, as you can see here, this is my Docker file. Okay, and under your particular your code, what is available in your GitHub, there I have a Docker file. Just let me see what is there in Docker file. Okay, so Docker file, if you see just a from, what is working directory, what is copy, what is run, why multiple run, what is expose, what is entry point. This everything will be covered in today's sessions. Okay, so I don't have to explain now here. Once we see the diagram, then we can it will be easy for you to this thing. So this one we understand. That means we have, if you have application here, D means whatever you have under here, slash dot D means whatever you have it in your working directory, current directory, basic working directory, it will be this thing. Okay, use that one. Based on that, it will be considered as for your applications. Image should be built based on that. But that means the application could should be available within your directory. Same directory you have to keep your Docker file. In my case, this is application core. Everything I have inside here. Let's say manifest I have, properties I have, root I have, everything I have. This under same directory I have. That's why I kept my Docker file here. Okay. If I keep inside, then somewhere it will have a issue. So keep somewhere in your main directory or root directory in this. Then we have a container. Container is basically a container basic running. Okay, I explained already. But in simple term, we can say it's a running instance of Docker image encapsulating the application and dependencies in isolated environment. You can see the characteristic. What is that? This thing. Containers can be started, stop, right, and restarted. You can stop, start this thing. Okay, because this is just an environment. It's isolated environment, right? You can have stop or start or do anything, and also isolated. Each container is isolated from the host system and the containers. Okay, and the dynamic containers can be scaled up or down based on demands possible. And we can have it here. Containers can be stateful. Containers can be stateful and stateless, right? So what is stateful and stateless in simple terms when it comes to the Docker, right? So when I say the okay, basically there are two different modes. If in container service and the in container and service, there are two different modes. One is the stateful and one is the stateless, right? So when I say stateless, basically nothing but is just the service, basically the service that is one that does not retain persistent data. That means you will not have the persistent data. This is good if you have much easier to scale update. Okay, if you want to update frequently anything that you can use the state that first one. Then if you have stateful means basically that you could persistent storage like your database persistent okay, for your example database. You don't have to think much now. We will learn this also as we go along. Okay, you just take a look this also same thing. How I can have this, how I can Docker run, because image is ready here, right? So once image is in place, I can use this one because image is ready mean I want to use here, no, I want to run it under my container. So I can use once I can complete, I can run these commands and I can run this one. Docker run, okay, d test mode, and mention the then your name, whatever name is there, basically container name. Basic, this is basically name. When I mention is a container name, then whatever container name you want to put, then your application with that tag. Okay, okay. Now we will see some hands-on how we can use this one. So container identification, we need to understand first thing. So when you create a container or Docker container, it is assigned a universally unique identifier or UUID, right? You have a unique ID for each and every container. This can help identify the Docker container among others. So this is basically this is for the only for the Dockers only. Okay, so Docker can identify the Docker. Okay, they can identify because they will not know which is what, right? So they need to identify. That is why they have there something UUID. Okay, that is your universal unique identifier. Example, uh, in my case, this is some of the thing. Example, we have a Docker run .tt. If I use this thing, you can see then this ID will create. For example, let me just run these commands. How will I copy this one? I think I need to. Yeah. First, let me see what is there here. I don't see anything here. I'm in the Docker directory. I don't have anything. See, it is being now coming. First, how we got this one? Let me tell you. Uh, Docker Hub. What is that name? That is Nginx, right? Nginx. As you can see, this is my Nginx okay, team. So let me go inside, and you can see the pool option. Docker pool. If I pool, you can use this command. So if see some versioning. Okay, how many tags are there? Okay, I have so many tags. I can use based on a tag or whatever. In my case, I can use latest also here. Nginx pool request. Okay. So this is basically already official listing. You don't have to. This is already available publicly. Nginx. Okay. So what I'm trying to do is that this Nginx I want to download in my local systems. First, what it'll do is if I use a run then run it. So in my case, what it does is first, if you just notice the message basically, as I run the command, where is that? Here. Okay, Docker run. Okay, then DTP for that is port, local port, and your for this Nginx port. If I mention here, unable to find images if latest locally. That means first always whenever I try to pull or do anything, it will first check in my local system. Okay, in my local Docker hub, in my local only, basically it'll check first. If it is available, they will use it. If it is not there, they will what they will do. You see, letters they have pushed it. They went directly. If it's not there, pulling from libraries, whatever Nginx. That means directly they went to the my GitHub. Sorry, Docker Hub. Here, Docker Hub they went directly. They pull these images basically. You see here, pull image from here. Okay, library start. So that means now, like I mentioned, I don't have because this is publicly available. That is why they are pulling directly from publicly that repository. That is your Docker Hub which is available, which I showed you here. Okay, they pulled it, but they image as tag as they use the latest one. Okay, then once you pull, they mention whatever they have this thing, they pull everything. Once it is completed, you get some ID number like that. Okay, now if you see, you get some ID like that. I guess we see something number ID, right? And if you see here, another latest version for this one also, this is what is saying status, right? Downloaded newer images for Nginx. That is my tag as latest. Latest, why latest? Because if you see here, there is a here latest, right? This tag they use, or you can go inside if you want. You can go inside. Uh, if you want, you can check here. We can check full details if you want to see more in details, basically. That again, you can check this way also if you want to see, if you want to understand basically all in depth. No, just go through with this one and understand it. Okay, if you see here, dash id everything is created here. No, dgs id and everything. If you same thing, in my case, dgs id will is that here is at the last it is a uh, besc, right? So if you see, this is a different one because it will be unique. That is why I say, okay, it will be created, it will be unique. You see here, it is a assign is a sorry, assign is a universally unique identifier. That will be unique, will not have a same this one. Okay, so now we are good. Now we have got one of the example, this one. So then what we can do is to help humans, Docker also allows us to supply containers name. Instead of this one, you can have a container name also. You can have. By default, if we do not specify the name, Docker supplies randomly generated name uh, from two words joined by a underscore. That how we can check that one. First, we'll see that one. If I use the Docker PS, what it does basically, it will show the running one. Let me see if I use Docker PS. And we have one more is the Docker images or image. I think it will work both. I think so. It will work both image and images. Yeah, but image will not have more arguments. So I will images is the thing. I'll just clear everything. So we can use instead of the Docker images itself. Sorry. Okay, Docker images we can use. Docker images, if you see here, uh, before if you see here, before I don't have anything. Okay, before ls in, okay, it is an image only directly. So if you see here, when I say Docker image, I can see this Nginx which was downloaded just now. That's tag as the latest, and this is the image ID. So every single the Docker basically, whenever Docker is image is created, it has the unique image ID for every time. Okay, and also created 2 months ago. That's taken from there. Okay, then we have this is my another one. This was I don't know when I used it before. This is my old one. This is taken from SCR, Azure Container Registry. Anyway, so I have two images now. Okay, if you want to see how many images are created, you can just use this one, Docker image. Or in my case, if I want to use the PS mean running. Okay, Docker image, we can see the Nginx. Uh, Nginx is there. This is a container. This is a container ID. That's what I'm saying. This is a container ID, and this is a what is that? 6 minutes ago. Then start time. Everything you can support. Which port will be exposed. If you see here, we enable this port 8080, right? That is what we can see here. So we can run if you want to run Nginx, we can run if you want to run this one. What we can do, be docker run, then mention the name web app container name basically. Okay, web app name is what web app mean whatever name you're given is basically web container name. My case, what I can this web app one. So before there, let me check whether I need to modify something. Docker run. No, 1 minute. Let me check somewhere. I which name I got? I have confused now. Which name I given? Anyway, so what we can do is we will see another example because this name I given for it is for name for container only I given, right? Let me check. Yes, I think it is running. That's why it's not. Okay, we will be it is already running. So anyway, it is already running the name. That's why we can use some other. Okay. We will also be okay. We can use this one. Details, sorry, ATAS mode. Okay. In ATAS mode, Docker container runs interactively and is standard input. Okay. These and all, I think it is not much this thing now, but yeah, you can check the later. You can read the understand that thing. Okay. And also we have another container in ATAS mode. If you want to run in ATAS mode, you can just put here this one. That's IT interactive and a T for terminal or TTY. You can say TTY or terminal. Okay. Then we have a DATAS mode. Same thing. We can use a D. D means a DATAS. Just mention D Docker run the container name. Then it will be a DATAS mode. Um, then we will have the removing the Docker containers. Let's say you have something. Um, Docker containers can be removed with the help of a Docker containers RM. If you have containers, let me see if I have it. Okay. So what we can do is Docker container as your RM container name. Okay. So as your sorry, not as your RM, container RM, the container name or container ID. In my case, if I see here, let me check. I think we have seen it. Container, huh? Container ID is there, no? I can remove this one using this ID. Okay. I can stop, I can do whatever I want. Whatever in my case, I want to remove it. What I can do is I'll just clear everything. 1 second, we will type Docker images. Okay. So I want to remove this Nginx. Right now you can see two, right? So if you see this one, it has a image PS. Sorry, Docker PS. Now I see this image is the Nginx is there. Okay, this is the image ID basically. Okay, then yeah, PS you can type now. Now we can see in the PS we have this is the image ID. This thing for Nginx. Okay, same thing for Nginx. We will have this one, right? We will have this one. This is a this thing, image as Nginx, and this is a container name. That means to run your Nginx, this one, this Nginx, we use this container ID or this container we are using it. Okay. So now, if you want to remove this one, what we can do is, you can just use this one, Docker RM, then mention the container name. That means if you again try with these commands, it will go up. Let's see what we can do. We can just mention Docker RM. Okay. Then we will mention Docker RM, the container name. So in my case, this is the container name that is hosted for my Nginx, right? So container name, we can take it. It's correct. Yeah. it is running first. Okay, it is what is saying first. We can't do now because what we did was it is like I mentioned, it is already running. No, PS, when I say it is a PS mean it is a running one. So we need to stop the this thing. Okay, so stop. What is the command here? To stop the containers. Only containers. I think I didn't mention here. Is it okay? Docker stop. Mention the same thing. Image ID. I think I have written somewhere. I don't know why I missed it. Docker compose we did. Docker remove. Okay, I think it is missing. Okay, so what we can do is we can use a Docker stuff and mention the what is the image name. Image. So we will take the image of this one, right? Engine X container ID. Let's see with container ID we can stop. Otherwise image ID we can try. Let's see. Okay. Let's see. Okay. So we can take the container ID itself. So now we can check once again. Same comments we can try this thing. Now I don't see if I try here the PS basically nothing but it is basically a it will show the entire running Docker images. Okay, whatever running it will show. In my case, like I mentioned, I have already stopped this gesture, so that is why it is not showing me now because I have stopped it, right? So now I can remove it. I think I will add these comments also. I think I missed it. Okay, now I have removed it. Now see same command I use as RM. Then this is again container name, which is this one. This container name I used it. Okay, now so if I want to remove, just Docker always it will be there. RM is nothing but removing. Now what you want to remove? Container, right? You want to remove the container ID, you can give it. So if you case container, if you given the container name is okay, or if you have mentioned container name, you can mention container name, or you can mention the container ID itself. So I think I have, yeah. Here you can see Docker RM basically same thing removing container name or the container ID. So anything works. Okay. And we will see the Docker RM container. If you have multiple, yes, you can have the, if you want to remove multiple, you can mention Docker RM, then multiple, whatever number of containers name or ID. Same thing we can do, they remove the all stop containers. Okay, prone. Okay, we will understand what is a prone again. For now, we don't have to think much. We can remove the everything. And we, if you want to remove something like remove all containers, stop and running. Okay, we stop plus running, you can say Docker RM F. F is nothing but it is a forcefully you're doing with the variable of this one, Docker PS AQ. Okay, so example, I think I given you example. Here example, this is for this one. Here is it for remove containers based on the filter. So this is just an example, but this is actual command. You can use these commands. Okay. Then we have a containers. Sorry, remove containers with Docker Compose. If you have like Docker Compose installed or running in your this thing, you can use the Docker dash Compose down. That means your Docker Compose every all application whatever you're running for particular in particular compose Docker Compose will be stopped. Okay. So let me check. I think we will because we need to do some more. Okay. Now what we can do is so we can check the Docker containers except basically we will not be doing much this one. We can explore that later if how you want to do. Okay. If you want to use this command also we can accept. That basically useful for troubleshooting and debugging or interacting with the process inside of running container without need to restart. Suppose in one of the containers that you have issue now, right? So how are you going to troubleshoot that one, right? You don't have to stop the container itself because, like container basically holds your uh, Docker image, right? So your application is running under container itself. Now, if you stop that one, mean that your application will be stopped, or maybe it not be working. So in this case, it is good that if you can use these commands and get troubleshoot like debugging, and you can interact with that and run some commands and see. So I think I given some comments also here. Let me check. Huh. Docker container, we can mention the X is the optional the container with the argument name. This argument name. Example, if you want to run, if you want to run a shell bash within a running container name, you can mention this. So example, this is a container name. You can use this command, Docker container, then accept, then mention IT, then bash. Then this will go inside a terminal, and you can run your script. I have given that example in next session, next this thing. You can maybe check that also later. And we have it that is our Docker has a concept known as restart policies. By default, if you see normally Docker, no, it will not restart everything. Uh, Basically, whatever is there, you need to based on your requirement, you need to define what is your requirement, right? So that you can use to control the behavior of containers. Container has their own behavior, so you can control again based on the policy. Okay, register policy has different meaning. We will have others as well in that. So when they exit, okay, when they exit, register policy defines what happens to a container when exits. When it exits, right, from your container. So what is basically the policy, like what how it has to get, whether it has to delay or it has to destroy anything or reboot, like that. Okay, whether it's due to a successful completion of its main process or error or being manual stop. Okay, then we can specify the restart policy by using the dash dash, then the policy, that is your restart flag with Docker commands. Okay, Docker restart dash dash restart, but we will have more in that policy. If I see, for the first one is default one, there's a no restart, no or no restart, both are same. That is your default. um, by default, Docker containers do not automatically restart unless specifies. So by default, when I say Docker container will not restart automatically unless you specify. So now if you want to restart or whatever you want to do based on the restart policy, you need to define here. So if a container exits, okay, it remains the stop state. Okay, it remains the stop state, and it's up to the user to decide whether to restart manually. So when the basically mentioning, it says that by default, the container would not basically restart. Okay, they will not restart unless you specify. You have to specify in your policy, Docker policy. Okay, restart Docker restart policy. So like if a container exists, it remains the stop state. By default, it will be in a stop state, but you need to decide now whether you want to run the this thing or not, want to restart or not. That is again depends on you. And we have another one that is always. Always basically with the always, this is the command you need to put here actually in your Docker file. Okay, dash dash restart always option. Docker will automatically restart the container every time it exists. Whenever it exists, it will automatically restart it, regardless of the exist status, whether it is stops there or starts there or any kind of this whatever is it will restart. This is useful for critical services that need to be running continuously. Of course, if you have this kind of requirement, in this case, you can use that one. So you can just use a Docker run, then dash dash, then mention the restart always till here. Restart always, okay, here, restart always, then whatever container name you have, you can put this one. Then we have a restart policy. Sorry, unless stop. So the unless stop based option is similar to always, but it it won't restart a container if it was stopped manually by user. Like you say, restart unless stop mean somebody if only manually they have stopped the container. In this six situation, it's not restart. Okay, so let's say you have a requirement like you wanted to stop the containers manually in this case. If we can have a where you can have a policy as that I mean setting restart unless stop. That means it will not restart basically and if you stop manually or any user. Let's say you stop the user as a user, if you stop the container, this will not be restarted. But if somebody is doing not somebody, basically the manual automatically got stop mean in this case, yes. In this case, you can it will get restart automatically. However, you can see, however, restart if the system is rebooted for some reason, system got rebooted or somewhere for any reason. Okay, in this case, Docker run, then we can use the unless stop, then container name. Then we have it on failure. This is also very useful. Or as you can see here, restart on failure option allows you to specify a maximum number of restart attempts before Docker gives up. You can also set a delay between restart attempts. If you have this thing, you can have. That means Docker run restart on 5 times. That means on 5 time failures means 5 times this you will try to restart your failures. Like whatever, let's say you're doing something now, first attempt you got fail, second attempt you got fail like that. It will be doing 5 times. Or it can be, you can also define again. If you have to attempt multiple distinct restart option, that you can define number of here is equal to then mention your number of attempts that I want to mention here. In my case, it is a 5. Okay. Then if I use this is again if you want to see the disk uses right matrix, if you want to see, you can say to monitor disk uses matrix within a Docker container. You can use the various commands and tools. Example, if you want to see total size for particular Docker space, we can Docker system df we can use it. Okay, if you use df, example, you can see the image size, container, local volume, build cache, total, how much for each stacking, the which is active, which is not, and if you see here, what is the size for each, and everything we can see here. Okay, proclaimable. So everything we can basically track here using the uh, Docker system df. Then I think we can complete this session. I think the first session we can complete. I think. All right. Okay, next we have a automatically delay container on exist. Container, if you by default, you can have this kind of also like automatically you can delete a container on exit. Interact with the commands. If you want to interact also, you can use these commands. You want to track this one, interact with the comment containers. So this is again another this thing applying. Okay, this is from again you can get it. Alpine. You can check it in GitHub. Sorry, not GitHub. Alpine. You can try here. This is a publicly available. See, this is again tag as a latest and Alpine. You can see here. You can pull it or whatever. In my case, what we do. Sorry, where is that? Ah, so run the container. Okay. So what it do basically? Uh, let me first copy these comments. Sorry, here. Okay, what I'll do, I'll copy this Docker run. Then okay. This is when I say this is one argument, if you just this here, we say automatically delay on container exit. When exit, it has to get delayed by default, right? So when that's a we given the run, they will run, but argument I given as RM, that is your remove. And before that, what it then it has to do IT, the interactive terminal or interactive, you can say TTY. That is your then your whatever you have an image with the tag. Okay. So in my case, let me just copy. So you can do whatever you want, but once you're done with your work, it one on exit, it will get deleted. Just show you so that this is see it is not available locally. They'll try to pull now from the this thing. See, they'll pull from again here. Then downloaded newer image for Ebola. This got down. See, it got downloaded now. Now, if you see the things, it is a hash. That means you are inside of your containers now, basically for this particular SPinner container. You are inside this here now. Now, I want to do some modification now, or install any tools or do a modification based on your decision. For testing, what we will do, we will try to do something. Now, you are now we came here, right? Inside a container. Now you are in list files in a current directory. That is your ls. If you see here, I can type here also because you are inside container now, ls. Now I can see everything here, whatever is there based on a container, what is required, they have everything here. Then I can also see next. If you want to run some commands also, you can run it like hello world from whatever you can run it. So in my case, I can run this also. Okay. So basically, you can in simple terms you can do anything what you want to do. Then we have if you want to install any tools, this you can use it. Just install this one, nano pt. You can run any command what you like. Okay. Then again, if you want to nano, we can save it. Instead of nano, I can use a bi also. In my case, I'll try to use a bi. Nano also if you want, I can use it. Depends on you. Okay. You can nano you can use the bi also. So I will see this also. Okay, now we are good. Now I just bi or beam. Then mention this one. No, okay, this spelling wrong. Sorry, I'm already inside. Correct. So bi file name. I have gone inside. Now I can type anything. Just I can just go inside mode. I sorry. This is from this is for testing. Okay, just for example, I can save it. Once you save it, just remember this application, this name. This is basically you can just mention colon then q right quit q for quit then yeah, this thing. Okay, you can just execute. Now if you see here ls. Okay, now what we have done, your file is, you can see the files, and we have installed other things also, right? Run some commands also. Now if you want to exit here, on exit, what happened now, it will exit the container itself. That means it will go up. Now let me see, exit. Now if I see again docker image, you will not get this one. Alpine is we installed here. Okay, Alpine is there, but it will got this thing deleted from your containers. Basically on exit. Okay, it got removed. But if you here in your cache, this thing local system will be stored like your what you call that in your this is your remote. If I see here PS, that is your this thing, you will not have anything because that got removed from your running state. Okay, same thing. Uh, okay, I think yeah, Tim. That's it for today's sessions because I think again it will take time for second sessions. Many things we have it here. Sorry, second session only we'll be writing the Docker. Just go through next week for next week. Just go through the. I was explaining this one, no? The structure pipelines here. If you see here, whatever I mentioned here, file. Same thing you can see here. Example, just giving a hint so that you can go through and understand. Docker file, right? First is this is a Docker file. First one. First always will be a from instrument. Okay, instruction. Sorry. What it does basically, the from instruction has the base image or subsequent instruction in a Docker file. So Docker file will write there's a so from basically the base image, whether it is from what basis. In my case, if you see here, in my case, it is from the particular that is a Microsoft is in .NET based system. Okay, that's a from, and we will have a directory. Then what is copy, what is run. So this all I have already mentioned. I mean, I have already made a note this one. You can just go through this one for next. Huh. This also what is arg and why it is used with example everything, because this is somewhere for me also it is new, this particular this thing. So that is why what I did was I made a notes also what it does basically, so that it will be easy for you to understand better. Okay, then we have a working directory is very common, this one. Okay, you can have multiple working directory as well. You can, for example, mean just you if you use this command. Okay, uh, then same thing we have it run uh, instructions, then we have copy instruction, how it does, what is the example. Okay, so all these basically this thing we will what we will do, we will take one live applications. What we will do, once we understand the syntax in our basically what is that called here, Docker file, right? Once we understand this one, what we will do, we will take an example of existing applications somewhere located maybe GitHub, wherever we get it, right? There are many things. We will try to write in Docker file and see how we can use that one as an image. Okay, how we can use as an image, then we will see. For now, just see the syntax, basically the Docker syntax, and also the instructions in what cases we can use what. That just go through with this one. Volume, I think for now you don't have to think much. Uh, for now you can learn, but later we can have, as we learn more, we can use that. This also is useful if you want to use with Docker instruction, sorry, user instruction, we can use this one. Says the user, the image will run as. If you want to run particular image by particular name of the user or this thing, then you can mention here. Okay, then we have it here. Anyway, so for now, I think we will not be discussing this part, Docker file part, because it is nearly 10 pages are there. So we will maybe discuss next week this particular things. For now, I think we are good here itself. Okay, so next week we will start this one, second module. That is our, I think, yeah. So next week we will start this sessions team. So image creations, management, and this thing. And also we will what we will do. We will create one registry file in our somewhere. We will do two things. Next week will be complete hands-on. This week I didn't give a hands-on. Why? Because the notes or some comments I missed to mention. So I'll mention that also. And second thing is that there's nothing to give any hands-on here for the first one. Just the overview we are giving today. Okay, because we can't run these comments anything, we should have some edge control. That is fine. So what we will do next week, we will be completely hands-on whatever we are doing today. If you see, just for your understanding what we are covering next week, working with Docker image, how actually images are created, right? We will do hands-on everything, like Docker image, what is why Docker image. Then we will have some example here, we'll explain this also. And then we will see the Docker image layers also, why it is important, this thing, right? Then we will understand about different container. I think this is already discussed in this thing. Anyway, this also we'll discuss later. So, yeah, this is all the instruction we have. I mean, this thing in instruction for Docker file. Once we are good with this thing, then what we can do, we can have the tagging. Okay, Docker, how we can tag them, and then we will have here tag Docker image. Here, I think Docker. Yeah, here you will have some of the hands-on also you can do here. Try to do some hands-on here, and this you don't have much here also to do. This you can run these commands also. Pushing storage history. This also hands-on we will do. Next we will do this also hands-on. Okay, then we will see what history managing managing images using CLI, how we can manage that also we'll see. What I'll do is I'll get some more comments also so that as a notes we can use it. Okay, for now whatever is there you just see what is there. But yeah, we will see this one, and this is important. We will cover this also. What we will do, uh, this will be complete hands-on, pushing Docker image to remote repositories like GitHub. GitHub also we will have. I think I have mentioned another one is for the Azure, Azure also. Third, another one is a pushing images to remote repository, that is our Azure Container Registry. Okay, that also we will use how to use it. This thing. What else? Applying filters. Okay, this. Yeah. Okay. Huh. So yeah, next week we will be completely full hands-on. I will make more some notes also, like comments and all. Some because I don't have a space to keep here. I will make some notes for that. Okay, I'll give it to you. So yeah, Tim. So for now we are good for today. Thank you for joining today's sessions.